All right, now we want to look at some linear and exponential models. It says, Beth is amazed at how quickly Allison was able to make a lot of money and decides she wants to in on the action. She asks her two friends, Quentin and Alicia, to help her come up with a plan. So Beth was content with the $10 a week, especially those first couple weeks where Allison was making basically nothing. But then pretty quickly, Allison took over. Consider Quentin's and Alicia's plans. Whose plan should Beth choose? You should start with $1, ask for 50% more each week. You could start with $1 and add another dollar each week. Ooh, I know which one I would do. Let's look at this. Okay. You start with $1, and then you ask for 50% more each week. So then the next week I'd have $1.50. And then you'd have 2 1/4. And then you'd have 3, we'll call it 38. And then you'd have 506. And then 759. And then 1139. Now, if you're asking what I'm doing, you should be able to figure out kind of the beginning, and maybe it got confusing. Start with $1, ask for 50% more each week. So you got $1. The next week you want 50% more, so that's $1.50, because 50% of $1 is $1.50. Well, 50% of 1.5 is 0.75. So the next week we get 225. 50% of 225 is 113, hence the 338. And then 50% of 338 gets us this difference, and gets us to jump that difference there more than the 113. So that's what the pattern is there. For Alicia, there was an extra I in the name up there. Okay, I got confused. You could start with $1 and add another. So for the first week, $1. Second week, $2. Third week, $3. Fourth week, $4. Fifth week, $5. Sixth week, ooh, look at that. Add another $1 each week. So pretty quickly, Quentin's plan came out better. If we look at the curve, 1, 1, 2, 2, 3, 3, 4, 4. So that's Quentin's plan. No, Alicia's plan, sorry. And then Quentin's plan is 1, 1.11, 2, 1.5, 3, 2.25, 4, 3, 38, 5, about the same. And then it starts to zoom. So 759, 759. And then 7, we got 11, so up here. So my curve's going to look something like that one. Ignore that random straight point. So Quentin's plan looks like it got a lot better. So I would go with Quentin's plan. Right, the functions to represent. Okay, so Quentin's plan, we started with $1, and then we got 50% more each week. So how I would think about that is 1 plus 50% more, so 0.5 each week to the x, where x is the number of weeks. So x is number of weeks that have passed. So a of x is going to be what was just whatever x was, right? So after 1 week, it's 1. After 2 weeks, it's 2. After 3 weeks, it's 3. Use your choice from question 1 to determine how much Beth will earn in week 10. So she took Quentin's plan. Quentin's plan was the $1 and then 1.5 to the x. And in week 10, I guess I should revise my answer, because I was thinking weeks from when we started, but it's going to be x minus 1 because it's going to be week 10. So if I plug that in, that's going to be Q of 10 is essentially 1.5 to the 9th. And I'll grab my calculator and say 1.5 to the 9th. And that's $38.44. If Beth and Allison both start using their exponential models to earn income at the same time, who will earn a higher income in week 12? Well, that was 1.5 to the 11th, which is $86 and we'll call it 50 cents. And then Beth's was, I forget what her function was called. We called it F, right? F of 12, that was the 0.005, the halfpenny, and then 2 to the 12th. So if I do that, 0.005 times 2 to the 12th, that's $20.48. So Allison earns more. Allison earns more. And I messed up the names. This should be Beth earns more. Silly me. Because Allison's the bottom one. Beth earns more. Use technology to determine when Allison's and Beth's incomes will be equal. Okay, so what I would do, and you should do this as I'm saying it, you go to Desmos, and you put in the two curves. So one was 1.5 to the x minus 1. And the other one was 0.005 times 2 to the x. You can also do this on a graphing calculator if you'd like. In fact, it might have been easier to do that based on the scale. Okay, I have to change my scale here. So I'm going to make my scale, I don't know, the hit right there. Okay, I can see it there. Okay, so I got the point 17.008 and 658.934. So incomes are essentially equal at week 17. As the number of weeks continues to increase, whose model will generate more per week? Well, if I look at these curves, I will quickly see, so I made Allison's blue and Quinton's red, that the red curve stays on top until we hit that intersection point at like 17-ish, and after that, blue's going to win. So that was Allison's model. Allison after week 17. Compare Allison's functions model. Consider the A and B values. Since the A value for Allison is, not the A value, the B value, silly me, is 2 versus 1.5 for Beth. That means Allison's going to win. Allison will eventually earn more. So it doesn't matter that the starting value for Allison is super low, a half a penny. What matters is the fact that we're doubling her money versus we're 1.5ing Beth's money. That's huge. The doubling versus 1.5 is a big difference.